The Subcommittee on Space will come to order. Good morning. Welcome to today's hearing entitled Exploring Our Solar System, the Asteroids Act as a Key Step. In front of you are packets containing the written testimony, biography, and truth and testimony disclosure for today's witnesses. I recognize myself for 5 minutes for an opening statement. Good morning. I would like to thank our witnesses for being here today to testify about future scientific exploration of our solar system and the recently introduced Asteroids Act. Planetary science has long inspired us to imagine what it would be like to visit another planet in our solar system. It has shown us that there are methane lakes on Saturn's moon Titan, icy plumes on Jupiter's moon Enceladus, and that humans can maintain a robotic presence on Mars. However, over the last few years, the administration has consistently cut NASA's Planetary Science Division budget. Meanwhile, NASA's Earth Science program has grown by more than 40%. There are 13 other agencies throughout the federal government that currently fund over $2.5 billion in climate science research, but only one agency does space exploration and space science. Congress has long been a supporter of planetary science, particularly as it pertains to asteroids. After the airburst over Chelyabinsk, Russia, that caused tens of millions of dollars in damage and injured nearly 1,500 people, this committee held 2 hearings on NASA's Near-Earth Asteroid Tracking Program and its efforts to fulfill the requirements of the George E. Brown Near-Earth Object Survey Act. Support for the detection and characterization of asteroids is not to be confused with the President's current proposed asteroid redirect mission, or ARM. It is no secret that this committee has expressed significant skepticism with regards to ARM. NASA's own experts have been critical of the plan. NASA's own Small Bodies Assessment Group recently said its benefits for advancing the knowledge of asteroids and furthering planetary defense strategies are limited and not compelling. Additionally, the NASA Advisory Council has warned that the ARM mission as currently defined, may pose an unacceptable cost and technical risk. This is not the type of review you want to hear from the experts that NASA has chartered to provide advice. While I am indeed interested in the opportunities offered by near-Earth objects, I continue to be concerned that the administration is not heeding the warnings of these experts for the mission that it has designed. Today we will also be discussing the bipartisan efforts of 2 members of this committee to offer a legal framework for the private sector to utilize celestial resources. The American Space Technology for Exploring Resource Opportunities in Deep Space Act, or Asteroids Act, is a bipartisan bill introduced by Congressman Posey and Congressman Kilmer. The 2 of them have worked very hard to put this legislation together, and I'm interested to hear what our witnesses have to say about the potential benefits offered by space resource utilization. It is my sincere hope that the administration will stop spending time on poorly designed and executed missions such as ARM and look to the private sector and scientists for input on the best way to maximize our limited resources. At this time, I yield my remaining time to Mr. Posey from Florida.
Thank you, Mr. Chairman, for holding this hearing, which will include discussion on H.R. 5063, the Asteroids Act. I'd like to thank my colleague and original co-sponsor, Congressman Derek Kilmer, for his work on this bill, and the 10 bipartisan co-sponsors we already have on this committee. Mr. Chairman, this is an exciting bill, both in subject matter and as a matter of practical legislation. Space exploration is inspiring, and today we will discuss the importance of a legal framework to encourage a new area of private space exploration. Today, private companies do not have legal certainty that if they obtain resources from an asteroid, that they can own them. The Asteroids Act would provide this certainty to American companies, and companies are empowered to conduct their operations without harmful interference. Asteroids can hold valuable minerals, some in impressive quantities, as well as resources essential for continued space exploration. I look forward to further discussion on this topic. Again, if you want American commercial space companies to get off the ground, we need to create the proper legal framework for them to do so. Thank you, Mr. Chairman. I yield back.
Thank you, Mr. Posey. I now recognize the ranking member, the gentlelady from Maryland, Ms. Edwards.
Thank you very much, Mr. Chairman, for holding today's hearing on planetary science, and I hope we do focus on the science, and I want to welcome our distinguished panel of witnesses this morning. The accomplishments in planetary science research and robotic exploration of the solar system are indicative of the exemplary work being done by NASA and its industry contractors, academia, and the non-governmental entities that comprise the planetary science community. The discoveries and advancements being enabled by NASA's planetary science program are in fact thrilling. Just weeks from now, NASA's MAVEN spacecraft will enter into Mars orbit for its study of the Mars atmosphere. In October, just over a month from now, it will be all hands on deck for our Mars orbiters and rovers when NASA will have an unprecedented opportunity to use these assets to observe C-2013A1, otherwise known as Comet Sighting Spring, as it passes near Mars and bathes the planet in dust from its coma and tail. It is fortuitous that MAVEN, which will be a key observer of this event, will have arrived just weeks before Sighting Spring's encounter with Mars. Finally, later this fall, the European-U.S. Rosetta Comet mission will make the first attempt at a controlled landing of a robotic lander on a comet. What this means to me is that we're getting real value from our investments, our current investments in planetary science. And in fact, I would point out that the authorization bill that was approved unanimously out of this subcommittee and out of this Congress balances those investments with other investments that we're making in the other important missions of NASA. Because a strong planetary science program is important not only to advancing our scientific understanding of the solar system, but also to detecting potentially hazardous near-Earth objects, providing scientific insights relevant to the long-term goal of sending humans to Mars, and to training of our future scientists and engineers. And I can't underscore enough the importance of NASA's programs, including planetary science, to inspiring the next generation. NASA's science missions provide concrete connections between learning science, technology, engineering, and math in the classroom and exciting projects in space, perhaps even ones that students dream to be part of one day. Mr. Chairman, I look forward to hearing from our witnesses on the many developments taking place in planetary science. I also look forward to working with you to ensuring that Congress provides the resources NASA needs for all its mission areas, including planetary science, to enable a robust and innovative 21st century U.S. space program going forward. And while my understanding is that the purpose of this hearing is to examine planetary science as well, I note that the majority has asked for a discussion on H.R. 5063, the Asteroids Act. The issues raised by the Act on resource utilization and property rights are important and interesting areas that I hope the subcommittee will continue to explore more substantively in the next Congress. Before I close, I also want to acknowledge the presence of our former chairman, Bart Gordon, with us here today, and say hello to him and thank him for his continued public service even outside of Congress. And I want to take a moment to remember a key figure in NASA's planetary sciences, Dr. Noel Henners, who passed away just this last Friday. Dr. Henners was a chief scientist of NASA, director of the Goddard Space Flight Center out in Prince George's County, where I live. He directed also the Smithsonian's National Air and Space Museum and was vice president of flight systems at Lockheed Martin, where he was responsible for Lockheed's work on planetary science missions. NASA's planetary science program wouldn't be what it is today without the contributions of leaders such as Dr. Henners, and our thoughts and prayers are with his family during this difficult time. I want to say in closing that we have a lot of issues to explore, and they aren't just about the United States. They implicate our partners internationally, and so as we move forward, let's think about our responsibility not just to U.S.-based companies, and we're concerned about those, but also to connecting our concerns with our international partners so that we can truly move forward in a 21st century manner for our space program. And I yield back.
Thank you, Ms. Edwards. I now recognize the chairman of the full committee, Mr. Smith, for his opening statement.
Thank you, Mr. Chairman. Planetary science teaches us about how our solar system works and provides clues about how it was formed. Planetary missions search for scientific evidence that microbial life could potentially exist on planets within our solar system. They also map the locations of minerals and potential water sources on asteroids, comets, moons, and planets that could be extracted for use here on Earth. One such mission, called New Horizons, is a robotic mission scheduled to reach Pluto next year. It will provide the first close-up images and measurements ever made of that dwarf planet. A mission to Europa could search for microbial life in the salty waters that lie underneath the moon's icy crust. The President's budget requests have made it clear that this administration does not consider planetary science a priority. Over the past 2 years, the Obama administration has significantly cut funding for NASA's Planetary Science Division. In June, the House passed the bipartisan NASA Authorization Act of 2014 by a vote of 401 to 2. In May, the House passed the Commerce Justice State Appropriations Bill, H.R. 4660, by a bipartisan vote of 321 to 87. The bill provides $170 million more to the Planetary Science Division than the President's budget request for fiscal year 15. The Senate Committee on Appropriations also approved a bill that would provide $23 million above the President's request. Congress has made it clear on a bipartisan and bicameral basis that we value the planetary science community and the important work that they do. Planetary science missions help lay the groundwork for manned missions. If the administration does not support planetary science, how can they claim to have serious interest in human space exploration? I hope that the administration is paying attention to today's discussion. Planetary research also has significant commercial interest. We now know that asteroids contain rare minerals that are in short supply here on Earth. Several U.S. companies hope to someday develop business models that leverage the findings of planetary science to identify and extract these resources. The legal framework to establish property rights to these resources has yet to be established. H.R. 5063, the American Space Technology for Exploring Research Opportunities in Deep Space Act, Asteroids Act, introduced by Representatives Bill Posey of Florida and Derek Kilmer of Washington, is the first bill to address important issues about the relatively new commercial intent to obtain resources from space. It discusses property rights for companies that find rare minerals and other materials in asteroids. It also directs the President to minimize barriers to growth of the industry. And, Mr. Chairman, I look forward to hearing from our witnesses today about their perspectives, especially on the Asteroids Act and the groundbreaking work that's being conducted in planetary science. I thank you, and I yield back.
Thank you, Mr. Smith. I now recognize the ranking member of the full committee, Ms. Johnson, for her opening remarks.
Thank you very much, and good morning. I want to join Chairman Palacio and Ranking Member Edwards in welcoming our witnesses to this morning's hearing. Hearings such as today's provide a clear reminder of the amazing advances that are possible when this nation makes a sustained commitment to investing in research and development. It is not an overstatement to say that the planetary science missions that will be discussed today would have been considered the stuff of science fiction not too many years ago. As I speak, a spacecraft is circling the planet Saturn and imaging its moons, and a robotic rover is preparing to climb a mountain on Mars, and even attempt to image a comet that will be visible to the Martian sky. A spacecraft is on its way to Pluto, and we are discovering and tracking asteroids that could potentially threaten the Earth. Just this past weekend, in conjunction with the comments that are made by both the chairman and Mr. Posey, I visited Brownsville, Texas, and the University of Texas at Brownsville's astronomy program and the site for the new SpaceX launching station. We're living in a wonderful time of scientific exploration, and I look forward to hearing more about NASA's planetary science program this morning. But we also need to hear about what problems need to be addressed to ensure that this record of achievement can continue. And with that, I want to welcome you again and look forward to your testimony. Thank you, Mr. Chairman. I yield back.
Thank you, Ms. Johnson. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witnesses. Our first witness, Dr. Jim Greene, has served in numerous capacities within NASA throughout his career and has served as NASA's Director of Planetary Science since 2006. Dr. Greene, an expert in space physics, has written more than 100 articles in referred journals primarily on the subject of Earth's and Jupiter's magnetospheres. He has also authored over 50 articles on the technical aspects of networks and data systems. Dr. Greene received his Ph.D. in physics from the University of Iowa. Our second witness Dr. Philip Christensen is co-chair of the National Research Council's Committee on Astrobiology and Planetary Sciences and Regents Professor at Arizona State University. His work in developing, building, and operating infrared cameras and spectrometers has been invaluable in studying the surface of Mars. As equipment designed by Dr. Christensen has mapped the surface composition, searched for habitable environments, and helped to select the sites for future Mars landers and rovers. He served on the NRC Planetary Science Decadal Survey as the chair of the Mars panel. Dr. Christensen is a fellow of the American Geophysical Union and the Geological Society of America and is the co-chair of the National Research Council's Committee on Astrobiology and Planetary Science. Dr. Christensen earned a BS in Geology and an MS and PhD in Geophysics and Space Physics from the University of California, Los Angeles. Our third witness today is Dr. Jim Bell. Dr. Bell is a professor in the School of Earth and Space Exploration at Arizona State University, an adjunct professor of astronomy at Cornell University, and president of the Planetary Society. His career is focused on robotic space exploration, and he has been involved in a number of NASA space exploration missions, including serving as the lead scientist in charge of the panoramic camera color imaging system on the Mars rovers Spirit and Opportunity, and as the deputy principal investigator of the Mastcam camera system on the Curiosity Mars rover. Dr. Bell is a markedly active and prolific planetary scientist, having authored or co-authored nearly 200 research papers in peer-reviewed scientific journals. His research is frequently featured in publications such as Sky and Telescope and Scientific American. Dr. Bell received his BS in Planetary Science and Aeronautics from the California Institute of Technology and obtained his MS in Geology and Geophysics and his PhD in Planetary Geosciences from the University of Hawaii. Our fourth witness is Dr. Mark Sykes, CEO and Director of the Planetary Science Institute. Dr. Sykes is co-investigator of the NASA Dawn mission to Vesta and Ceres and has chaired many NASA review panels and advisory groups. Dr. Sykes received his BA in Physics from the University of Oregon and a Master of Electronic Science degree from the Oregon Graduate Center. He then went to obtain a PhD in Planetary Sciences and a Juris Doctorate from the University of Arizona. Our final witness, Professor Joanne Gabrinowitz, is Professor Emerita at the University of Mississippi and was the editor-in-chief of the Journal of Space Law. She currently serves on the National Geospatial Advisory Committee, the NASA Advisory Committee's Planetary Protection Subcommittee, and the U.S. Department of Commerce's National Oceanic and Atmospheric Administration's Advisory Committee on Commercial Remote Sensing. She is also a director of the International Institute of Space Law and the chair of its Publications Committee. She received her BA at Hunter College and her JD from Yeshiva University. Thanks again to our witnesses for being here today. As our witnesses should know, spoken testimony is limited to 5 minutes each, after which the members of the committee will have 5 minutes each to ask questions. I ask unanimous consent at this time to enter into the record a letter from Planetary Resources and without objection. I now recognize Dr. Greene for 5 minutes to present his testimony.
Mr. Chairman and members of the committee, I'd like to thank you so much for the opportunity to appear today and discuss briefly the status of NASA's planetary science program. NASA's planetary science missions continue to explore our solar system in unrivaled scope and depth. NASA spacecraft have visited every planet as well as a variety of small bodies that have much to tell us about the solar system's formation and evolution. We are seeking answers to fundamental science questions that guide NASA's exploration of the solar system. These questions are: how did our solar system form and evolve? Is there life beyond Earth? And what are the hazards to life on Earth from our solar system objects? With an exploration strategy based on progressing from flybys to orbiting to landing to roving and finally to return samples from planetary bodies, NASA advances the scientific understanding of our solar system in extraordinary ways, while pushing the limits of spacecraft and robotic engineering, design, and operations. Briefly, beginning in our inner solar system, NASA's Messenger spacecraft has been orbiting the planet Mercury now for more than 2 years. Mercury's surface has been shaped by impact and volcanic processes, We also find that Mercury harbors abundant volatiles in permanently shadowed craters. At the Moon, the LADEE mission successfully studied the very tenuous lunar atmosphere and dust environment until its planned impact on April 17th. With LADEE, we also successfully tested high-speed optical communication back to Earth. This technology will be a critical element in our future Mars missions and beyond. At Mars, the Curiosity rover has landed in an ancient riverbed. It has determined the age of the surrounding Martian rocks. It has found evidence that the planet could have sustained microbial life and taken the first readings of radiation on the Martian surface. Launched in November last year, the MAVEN spacecraft will arrive at Mars on September 21st and will explore the red planet's upper atmosphere, ionosphere, and their interaction with the sun and the solar wind. MAVEN will also be in time to study a comet that will fly very close to Mars on October 19th. From the furthest reaches of our solar system, comet sighting Spring has traveled for more than 1 million years, and for the first time since it was formed, will come close to Mars, flying into the inner solar system. Sighting Spring will pass within 130,000 kilometers of Mars, blanketing it with cometary material. Many of NASA's space missions and ground-based assets will be studying this once-in-a-lifetime event. Future NASA missions to Mars include a new Mars rover planned for launch in 2020. For the first time, NASA scientists and university scientists will use Mars 2020 rover experiments to carefully select a collection of rock and soil samples that will be characterized and stored for potential return to Earth. The Mars 2020 rover will also help advance our knowledge of how human explorers could use natural resources available on the red planet. Asteroids are important objects within our solar system, deserving intense study. After successfully orbiting the huge asteroid Vesta in March of next year, Dawn will successfully get into orbit around Ceres, the largest object in the main asteroid belt. We're also developing a robotic asteroid rendezvous and sample return mission called OSIRIS-REx. The first U.S. mission of its kind, OSIRIS-REx, is on track for launch in 2016. With recent congressional support, NASA's enhanced funding for the near-Earth object survey and characterization activities necessary to protect our planet and also support human exploration and technology has made steady progress. In just over 15 years, we have found over 11,000 near-Earth objects. We are making great progress, but we have a lot yet to do. After 9 years of travel, in July 2016, the New Horizons spacecraft will make its historic flyby of the dwarf planet Pluto and its moons. It will then venture into deep space and into the Kuiper Belt. In summary, our future missions will continue along this path of exploration, discovery, innovation, allowing our scientists to answer questions I posed earlier. Again, thank you for the opportunity to testify today and your continued strong support for NASA's Planetary Science program. I look forward to responding to any questions you may have.
Thank you, Dr. Greene. I now recognize Dr. Christensen for 5 minutes to present his testimony.
Mr. Chairman, thank you very much for the opportunity to speak with you today. Three themes are going to run through my testimony today. The first is that planetary science has excellent opportunities for continuing the exploration of our solar system. These opportunities have been clearly defined in the recent National Research Council's Planetary Science Decadal Survey. Second, the significant reductions in the level of funding from NASA's Planetary Science Division from the previous decade have dramatically slowed the pace of new missions and future discoveries. And third, the lack of year-to-year stability in funding is having a serious impact on our ability to develop a long-term plan for planetary exploration. The NASA Planetary Science Program has made a remarkable series of discoveries over the past several decades and is poised to continue to make major discoveries based on the plans outlined in the Decadal Survey. That report represented the consensus of the U.S. planetary science community and clearly defined a program centered around a suite of missions of differing sizes to explore the highest priority objects in our solar system. The survey emphasized balance, both the importance of a balanced suite of small, medium, and large missions, and also the importance of a balance of destinations. In the 3 years following the release of the decadal survey, the key recommendations and priorities remain essentially unchanged, and they continue to have the strong support of the planetary science community. The primary challenge that the planetary program has faced in implementing the survey's recommendations have been the significant reduction in funding that occurred almost immediately after the report was completed. In fiscal year 13, planetary funding was reduced by over 20% from previous years and has remained close to that level since then. Congress has worked extremely hard to increase the budget in each of the past 2 years, but the funding remains well below what is needed to implement the decadal survey recommendations. Equally important, the year-to-year uncertainties in funding have made long-term planning extremely difficult. Planetary missions require many years to implement and operate, and without stable funding, these new missions either cannot be started or their development is stretched out with the inevitable increase in mission cost. In spite of these stresses, there have been some major positive advances. In my view, the 3 key areas of progress and caution are the following. First, the highest priority decadal survey recommendation to begin the campaign to return samples from Mars has been initiated with the approval of the Mars 2020 rover. This first element will focus on collecting the samples. The follow-on missions will retrieve those samples and bring them back to Earth. In order for the sample return campaign to be successful and to remain true to the priorities laid out in the decadal survey, it is essential that this rover remain focused on collecting and caching a suite of high-quality samples. Looking to the future, NASA also needs to start now to begin developing the technologies that will allow us to bring those samples back to Earth. Europa was the second highest priority flagship recommendation in the decadal survey, and this mission has received support from Congress and NASA through the plans to request proposals for instruments to be carried on a future mission to explore Europa. This is a major step towards exploring that planet, but it's only the beginning. The mission will require significant new funding to be implemented. In order to maintain the balance within the planetary science community, it is essential that the outer solar system remain a key part of NASA's portfolio. While the continued support for Europa from Congress is very encouraging, the commitment to start this mission needs to be made in earnest. And finally, the reduction in planetary funding has led to a delay in starting the next New Frontiers and Discovery missions. The next new Discovery mission is being initiated, but there are no plans to work on the next New Frontiers mission. These small and medium-sized missions are key elements of the overall strategy for a balance of mission sizes. With regard to human exploration and the robotic program at Mars, Mars Science Program can and should play a major role in the long-term goal of sending humans to Mars. Much of the information that will be required to safely land and return humans from the surface is being obtained by the robotic science program. The properties of the surface, the nature of the atmosphere, the location of water, these are all areas of intense investigation by the ongoing Mars Science Program. In summary, planetary science and exploration have virtually unlimited opportunities. These opportunities have been very thoughtfully outlined. NASA is ready to explore the amazing places of Mars and Europa, and we look forward to the opportunities to complete that exploration. Thank you very much.
Thank you, Dr. Christensen. I now recognize Dr. Bell for 5 minutes to present his testimony.
Thank you, Mr. Chairman, members of the committee, for the opportunity to appear today to discuss the future of one of our nation's crown jewels, which is NASA's Planetary Science and Solar System Exploration Program. I'm a professor in the School of Earth and Space Exploration at Arizona State University, and I also serve as president of the Planetary Society, the world's largest public space advocacy organization, and today I'm representing about 45,000 members of the society. We're a nonprofit independent organization of private citizens dedicated to advancing space science and exploration. The Planetary Society believes strongly that planetary exploration is a crucial program in a balanced NASA, and that this exploration should follow the path recently defined by the National Academy of Sciences Decadal Survey of Planetary Sciences. I'm also a professional planetary scientist, so I brought some pictures. We can't talk about the beauty of our solar system without showing some examples. So let's put the next slide up, please. The members of the Planetary Society respond to planetary exploration for many of the same reasons much of the public does. It's bold and daring, like Curiosity here, having landed on Mars in 2012. It tackles some of the most fundamental questions that humans have been asking for millennia. Where did we come from? Are we alone? How common is life? And can it take hold on other places besides Earth? Next slide, please. As described in more detail in my written testimony, for the past 50 years, planetary science has made tremendous progress toward answering these questions. But like the tracks from the Curiosity rover here, we've only scratched the surface. Recent planetary science missions reveal a solar system filled with worlds begging for further exploration. Recent discoveries that you've heard about include water ice on the moon's poles, evidence for an early warm and wet climate on Mars, liquid water oceans under the surface of Jupiter's moon Europa, shown in the next slide here, this gorgeous mosaic from the Galileo mission, and liquid hydrocarbon lakes on Saturn's moon Titan, shown in the next slide, one of those lakes showing here glinting in the sunlight from this Cassini mission view. At the same time, astronomers have discovered hundreds of new planets orbiting other stars, allowing scientists to study how other planetary systems formed, what they're like, and how they teach us about our own home. The Planetary Society is proud to support them and in many cases partner with NASA in these endeavors. Among the requests in your invitation letter, you asked me to address concerns that we have about funding levels for NASA's planetary science program, as well as to provide feedback on HR 5063. Next slide, please. Regarding NASA funding, NASA's planetary exploration program seems healthy today because of all the exciting missions and discoveries currently underway, but it's important to note that today's successes were enabled by strong and consistent funding from the previous decade. It's the funding trajectory looking forward that is concerning, and that's where we believe there's a crisis for planetary exploration. The consistent stream of publicly exciting, scientifically compelling missions that we've all come to expect of NASA is coming to an end, largely because of proposed cuts to planetary science. Now, to be clear, Congress has helped to restore some of that funding, and we thank you very much for that, but the long-term outlook for planetary science still remains at risk. And this chart that I just had up there shows that NASA had an average of about 6 new missions per year in the previous decade, the launch rate of about 1 per year, and that record of launches and missions is what has led to this golden age of planetary exploration that we're in. Over that time period, NASA's Planetary Science Division budget averaged about $1.5 billion per year, or less than 10% of NASA's total annual funding. But since 2013, proposed planetary budgets have been cut below that historic average, and the average number of missions in the pipeline has plummeted in half, and indeed only 4 launches are planned to occur before 2020. So the result is a de facto policy of withdrawal from some of the most exciting and scientifically compelling work that NASA does. We believe that there should be more of these missions, not fewer. Next slide. Regarding the Asteroids Act, the issue of resources on asteroids is particularly compelling from the scientific perspective. Lots of interesting questions about the history of Earth's water, how do large impacts from large asteroids like Eros, seen here, influence the development of life on our home planet, which asteroids represent impact hazards. And the issue is also compelling as we begin to imagine a future when humanity is moving outward beyond our home world. The Planetary Society recognizes that an agreed-upon policy regarding property rights for resources mined from asteroids will eventually be important for commercial investment. Since this is an area of current controversy among specialists, we advise careful thought and deliberation before moving forward in this area, and we embrace HR 5063's call to develop the frameworks necessary to attract commercial investment. In closing, over the past half century, next slide please, discoveries in planetary science point to a rich and diverse solar system and provide tantalizing clues as to whether life exists elsewhere. The public, like the young people shown here who watched and rooted for Curiosity's daring landing on Mars in August 2012 in Times Square, is clamoring for planetary exploration, and students and their teachers are inspired to learn and share more about science and engineering and to search for deeper understanding of the worlds around us. NASA's planetary science program has a clear plan in the Decadal Survey, has the people in place to continue the journey, and the question is whether it will be made a priority and given the resources to meet the challenge. We strongly believe it should. On behalf of the members of the Planetary Society, I'd like to again thank the committee and the Congress in general for their solid support of America's planetary science exploration program over the past several years. I'd also like to thank you personally for the opportunity to address you all today and to share my own thoughts on the importance of NASA's planetary exploration program for the nation and for the world. Thank you, Mr. Chairman.
Thank you, Dr. Bell. I now recognize Dr. Sykes for 5 minutes to present his testimony.
Thank you. Mr. Chairman, members of the committee, thank you for the opportunity to appear before you today. And I would also like to express my deep appreciation for your continued support of solar system exploration and the support of Congress in these kind of recent turbulent times. It's much appreciated by the community. I'm going to focus on two topics in my remarks: funding level for planetary missions and the asteroid retrieval mission. I'm concerned that our planetary mission aspirations and goals seem disconnected from available resources at all levels, and that priorities can only be inferred after the fact. For instance, it's very good news that after the latest senior review, all planetary missions in their extended phase that were reviewed will continue. This is not an unexpected outcome. However, the administration's FY15 NASA budget proposal did not include funds sufficient to cover this possibility. It's $35 million short. These funds are requested in a separate Opportunity Growth and Security Initiative. What's the plan if we are in CR all year or this initiative is not passed? On the larger scale, we would all like to see the recommendations of the NRC Planetary Decadal Survey implemented. These call for the restoration of a competed discovery mission proposals every 24 months, the cadence it had in its first decade, instead of the recent once or twice a decade. The Decadal Survey also calls for another round of competitive New Frontier proposals in this decade. If one adds to this the administration's Mars 2020 flagship initiative, desire among many to have flagship mission to Europa, the continuing missions, the foundational research and data analysis programs, and technology development programs, it's simply not possible to do everything with a planetary budget of $1.3 billion a year, or even, if we go to two flagships, $1.5 billion a year. If our competed mission programs are not restored, the United States, as just been mentioned, will have few assets operating in the solar system by the end of this decade and beyond. I am concerned about ongoing budget pressures on our continuing missions and losing our skills and capabilities that are maintained and grown by our research programs, which have suffered collapsing selection rates in recent years. We need to have a transparently rational basis for a planetary budget that embraces in part a longer-term vision than the year-to-year chaos to which it's been subjected in recent years. I would suggest that this has two components: a predictable baseline program and a flagship program. Long-term baseline planetary programs should be built on competed missions, competed research and technology programs, consistent with the decadal recommendations. This budget should be very predictable from one year to the next. Flagships are a great value as well, but because of their large expense and cost volatility expected from ambitious projects, the costs of mission studies, instrument development, mission operations, and science should be in a separate flagship program line. The mission target makes no difference. I'd like to go on to the asteroid retrieval mission, and I apologize for being a little negative perhaps on this. The NASA Advisory Council finds that this is not a substitute for a human mission to an asteroid in its native orbit, and the NRC Committee on Human Spaceflight finds the retrieval part of ARM to be a dead-end element. The NASA Small Bodies Assessment Group most recent findings state that ARM's science and planetary defense benefits are not compelling, and that significant uncertainties in our knowledge of the ARM targets, small asteroids or boulders on asteroids, contribute significantly to schedule and cost risk and the risk of mission failure. ARM is poorly conceived and poorly designed. It lacks fundamental knowledge of its target objects, and strategically does not advance human exploration, does not advance science, does not advance planetary defense, and does not advance understanding of the in situ resource utilization of near-Earth asteroids. In addition, the cost figure of less than $1.25 billion given at the most recent SBAG meeting strains credulity. The OSIRIS-REx mission, which has been mentioned previously, is returning 60 grams to 2 kilograms of near-Earth asteroid material to the surface of the Earth for a cost of $1.05 billion, which includes the launch vehicle and $60 million in headquarters-held reserves. We do not know what is in the ARM number, but it is hard to believe that for an additional $200 million, our ARM is going to return 500 metric tons of asteroid material to retrograde lunar orbit using new technology not yet developed and tested on targets not identified and fully characterized to satisfy Level 1 requirements not yet specified with an unknown level of risk acceptability. We can always find some benefit for whatever we do in space. That's what we do. But ARM sets an awfully low bar for rationalizing a major space initiative with a likely multi-billion-dollar price tag. Thank you.
Thank you, Dr. Sykes. I now recognize Professor Greenewitz for 5 minutes to present her testimony.
Thank you. I'd like to thank
Get your mics on.
Thank you. I'd like to thank the committee for the opportunity to address the Asteroids Act. You've provided 4 specific questions, and I'm delighted to respond. The entire text of my testimony has been submitted for the record. Current law. Current law is an amalgam of laws that address existing commercial activities. United States law regulates launches and reentry, the technology, financing, and behavior of various payloads, as well as related activities, intellectual property, for example. Laws were passed for specific space-related applications as their technologies matured and were available for commercialization: communication satellites, launch vehicles, remote sensing, and GPS. To the extent that a private asteroid mission uses any of these applications, the law that governs the application will also govern that part of the asteroid mission that uses them. There is one federal court case regarding an asteroid claim. The plaintiff alleged ownership of an asteroid based on a registration claim made by him on an online registry. He asserted that the United States infringed his property rights and sought compensation for parking and storage fees, as well as special damages. The case was dismissed by the district court and lost on appeal. The court held that the plaintiff appellant did not present a claim for which the district court may provide relief. Potential impacts of this kind of legislation on treaties. The potential legal impact of this kind of legislation is likely to be modest. The potential political impact is likely to be sizable. Opinio juris, legal opinion, is crucial to developing the meaning of treaties. There will be disagreement regarding the meaning of this kind of legislation, and some of its terms will be challenged at law and in politics. This is because there is no legal clarity regarding some of the issues that the bill addresses. The treaty regime seems to allow private sector entities to extract resources if those activities are consistent with international law and United States obligations. However, the ownership status of the extracted resources is unclear. Space is a global commons. Unlike other global commons, there is no agreement as to whether title to extracted resources passes to the extracting entity. In the absence of an agreement, legal opinion is divided. No claims have ever been made in space. Therefore, the status of an intentionally asserted superior right based on a first claim is a question of first impression. The use of first-in-time claims were raised early as they applied to geosynchronous orbital slots. Some nations championed a slot allocation system based on first come, first served. Others advocated using equity principles. These two positions continue to compete in a complicated and highly politicized legal regime. The competition has produced results such as distinguishing between access and appropriation, as well as creating different categories of orbital allotments and assignments. Attempts may be made to apply these kinds of distinctions to asteroids. There is need to clearly identify which federal agencies will be relevant to an asteroid industry and the specific responsibility of each agency. A private sector asteroid industry is an unprecedented enterprise. It raises novel issues requiring a wide range of expertise. An interagency structure ought to be considered like the ones that formally govern GPS and commercial remote sensing. These feature a formal agreement among a lead agency and other agencies to work in coordination. Each agency houses a particular expertise relevant to some specific aspect of the industry. One of the greatest challenges is establishing a uniform licensing and regulation of activities on orbit and at the asteroid. At this time, no agency has a specific congressional grant of on-orbit authority. Contemporary space issues such as orbital debris, space traffic management, planetary contamination, and satellite servicing have already caused some agencies to take regulatory action or make internal procedural requirements that go beyond licensing and operating satellites. These administrative actions demonstrate attempts at a nascent on-orbit authority. There needs to be a specific coordinated grant of on-orbit authority to agencies best suited to regulate an industry of this nature. In conclusion, the bill addresses some unprecedented issues. If made into law, it should be expected that there will be both legal and political challenges to some of its terms. International space law contains many gaps and ambiguities. It is logical and appropriate to attempt to resolve those ambiguities in favor of U.S. national interest. At the same time, the final results must be consistent with international law and the obligations of the United States. I thank the committee for giving me this opportunity, and thank you for your work to further develop space law.
Thank you, Professor Gabrinowitz, and I want to thank all the witnesses for their testimony. Reminding members that committee rules limit questioning to 5 minutes. The chair will at this point open the round of questions. The chair recognizes himself for 5 minutes. Dr. Greene, NASA's 2014 Planetary Mission Senior Review Panel recommended continuing all 7 missions that were up for review. However, the President's fiscal year 15 budget request only included funding for the extension of the Cassini mission and the Mars Curiosity rover. The President's Opportunity Growth and Security Initiative would provide an additional $35 million for mission extensions, but is unlikely to pass Congress. Where will the money come from to pay for the extensions of the other 5 missions? And at what point does extending older missions threaten the creation of new missions?
Well, that's a very good question, and of course, my understanding is that Congress will pass a continuing resolution. And it's within that continuing resolution that we have the framework to be able to continue our missions as we have in fiscal year FY14. Congress, of course, goes through the appropriation for the overall budget of Planetary, and we will execute that, and we will see at that time what the budget level is and the prioritization that we'll have to do to be able to maintain our mission fleet and bring in the quality data that's currently coming in.
So I guess as a follow-up to my second part of the question, at what point does extending older missions actually threaten the creation of new missions? Can you kind of elaborate a little more directly on that?
Of course. The very first recommendation of the Planetary Senior Review, which often gets overlooked, is that the 7 missions that were reviewed were absolutely incredibly important. In other words, they provide outstanding value for the funding that we currently have that manages those missions. We don't have to launch them. They're on orbit. They're doing outstanding science, tackling some new questions that relate to the planetary decadal, and are making excellent progress. So in the opinion of the community, and certainly in the opinion of the senior review as represented by the community, these missions we must find a way to continue on their operations. Of course, funding that is appropriated will allow us then to determine the schedule of our next new opportunities. And we're currently working on the Discovery Announcement of Opportunity as directed by Congress. We're happy to state that we anticipate getting the release of that Announcement of Opportunity in early October.
Professor Gabrinowitz, the Asteroids Act mentions the phrase first in time. When describing property rights for resources extracted from an asteroid, would you please provide a definition of first in time and give a context for its use?
Thank you, Congressman. Actually, I can't, because there is no definition in space law for first in time. I haven't researched that specific question, but I would look to other law. Property law, for example. In the United States, the history of claims has been if you are the first to claim land and you stay there and you work the land and you produce value from the land, then your claim is perfected. We see that in things like the Homestead Act and the Oklahoma Land Rush, and that's where my understanding of that comes from. But at international law, international space law, that is a term of art that doesn't exist.
Does the Asteroid Act have an impact on international treaties that the U.S. is party to?
Yes, the United States was a leader in developing the Outer Space Treaty and the 4 core treaties. The United States is bound by the terms of those treaties, and something like the proposed legislation will catalyze a debate as to whether whether its terms are consistent with the Outer Space Treaty and other relevant treaties, and the United States will definitely be a part of that process.
In Section 51203 of the bill, subsections B and C talk about freedom from harmful interference and the need to avoid harmful interference when conducting resource extraction on an asteroid. Would you define the term harmful interference and provide the committee, again, a better understanding of the context?
The term harmful interference can be found in Article 9 of the Outer Space Treaty. When negotiated, that was intended to refer to things like contamination, environmental degradation, one country conducting experiments that precluded the ability of other countries to conduct experiments. It did not have any application to commercial entities or private sector entities regarding claims. At that time, it was only as it referred to nation states and their national space programs.
All right. Thank you. I now recognize Ms. Edwards.
Thank you very much, Mr. Chairman, and thank you for that time. Thank you, Mr. Chairman, and thank you to the witnesses. I want to come to a couple of clarifications. I think it was Dr. Bell when you talked about the up and down resourcing of planetary science, and I think that we share that concern. In the authorization that passed in this committee, we established an authorization level that was actually consistent with what the appropriation was. And I noted on your chart, though, and maybe we could clarify this later, that it doesn't seem to reflect the actual dollars that were appropriated. And so for fiscal year 2014, for example, the actual appropriation was $1.345 billion. And I recognize that that is not what it had been at its peak, but it's one, higher than what the President's request was, but also reflects the notion that this committee, I think, is trying to get back to some more consistent funding levels and a balanced mission approach to planetary science. And so maybe we could talk offline about your numbers and our numbers too.
Absolutely, be happy to do that.
And then Dr. Greene, if you could, on the issue of the continuing resolution, I just want to hear some clarity as to whether you believe that postponing new starts would have any impact on planetary missions that have required launch dates that are due to planetary alignments.
Yeah, our current plan is indeed to release the next discovery announcement. This keeps it on track for the community to be able to complete their development of their proposals and submit them by about the December-January timeframe. We then go through an evaluation period with announcement later in that fiscal year. Our plan then is, of course, to keep our new missions on track to the best of our ability and as the budget will allow. Throughout this particular fiscal year, there's no need for a large influx of money for the discovery program because we're primarily going through receiving proposals and going through the appropriate...
for the next fiscal year or the current fiscal year?
For the upcoming fiscal year. Yeah. Because we'll be going through proposal evaluation and then selection.
And so if a continuing resolution goes through December, you still are on track at least through the beginning
Correct.
of the year
that would
with
be
the missions
point.
that are afoot, and then you would wait to see what the actual appropriation is beyond the continuing resolution.
Indeed.
Thank you very much. I want to go to the questions that Professor Grabinowitz mentioned. And, do you believe, given the things that you've outlined, the gaps that you've outlined in terms of our confluence of international law and domestic law and policy and relationships, that it is premature to proceed with the Asteroids Act at this point?
My professional opinion is the Asteroids Act, as written, is very, very vague and uses terms of art in novel contexts that I have not seen before. So without some groundwork, and by that I mean political, it could be premature.
And are these the discussions on the international context, are those ongoing right now in terms of the implications of international law and treaties at this point?
Well, yes, there's the UN Committee on the Peaceful Uses of Outer Space that continues to meet every year. There's a counterpart in Geneva, the name of which is escaping me right now. But the discussion of international treaties and space law is an ongoing activity at the United Nations and elsewhere.
But given the status, we could easily, this committee could postpone our consideration, understanding the importance, but to some additional, more in-depth explorations in the next Congress?
Well, with all due respect, I don't know the activities that brought it to the committee today. So I don't know what's going on behind it. I don't know the urgencies or not. Strictly reading the text and based on legal knowledge, it definitely needs work.
So we need to fill in some holes. Thank you very much, and thank you to the witnesses.
I now recognize Mr. Brooks.
Thank you, Mr. Chairman. This is for Dr. Greene. What is the planetary science community's position on using the Space Launch System for planetary science missions?
I'm really happy to tell you that as our Europa mission is in its pre-formulation activity, we have indeed connected with human exploration and understand the status of the development of the SLS. The SLS can potentially provide us an enormous opportunity to rapidly reach an outer planet's target, and may fit well for the very first time with our Europa initiative that would be launched in the 2020s. So it's under study right now. There's no firm commitments, but I'm happy to say that it does look promising.
Dr. Sykes, what is the consensus in the planetary science community on whether there is a scientific value expected from the NASA asteroid redirect mission?
Well, I would say it's not a unanimous opinion, but it's not a something that brings back the most bang for the buck, if you will. That there are higher priorities, such as we want to characterize the near-Earth asteroid population, to have a survey of that population from space in order to better understand what the real components are, rather than an expensive mission to one small target that's not characteristic of the size of objects that represent a danger to Earth, or the population of the near-Earth asteroid population as a whole. So there's the science support is weak.
Ms. Grabinowitz, early on you state that, quote, no one agency houses all that will be needed, end quote, to appropriately oversee private sector asteroid resource recovery, going on to claim that the system as it stands, quote, will produce unnecessary risk that is counterproductive to industry, end quote. Could you please expand upon what this risk might look like?
Well, yes, the activities of asteroid mining have never been dealt with before. And at the same time, there are other activities like space situational awareness, space traffic management that are equally evolving and have aspects that are relevant to asteroid activities. So different agencies have different responsibilities regarding those other activities, And there needs to be a coordinated discussion so information can go from one agency to the other. And when another activity or an event emerges, which is a case of first impression, the agencies can discuss how to deal with that. And we have two very good models. One is the interagency MOU that is used for commercial remote sensing, and also the interagency direction given by Congress for the governance of GPS. So I would suggest looking at those models and proceeding. That way, a company will know who's responsible for what. Without it, a question will arise, and only then do you start to look around to see who may know how to handle it. And that's unpredictable.
Thank you. This is for the entire panel. Whoever wishes to answer it, go ahead. And this is a GOP SST staff question. Quote, Congress has been clear in its support for NASA's planetary science missions and continues to propose funding it at higher levels than the President's budget requests. Why do you think the administration continues to cut NASA's planetary science division? End quote. Whoever would like to address it in the time I have left.
Well, I would just say that it has other priorities. I think it ranks other activities within the agency higher, and that's how it chooses to allocate the resources. We might not agree with that. Congress certainly doesn't agree with that, but it's the hand that we're dealt with.
Any specific programs that you believe the administration is placing as a higher priority rather than planetary science?
I don't know, everything?
That's pretty broad. Anyone else want to add to that? Hearing no additional response, Mr. Chairman, I yield back.
At this time, I recognize Mr. Kilmer.
Thank you, Mr. Chairman, and thanks to the entire panel. I appreciate the comments about NASA's planetary science programs and your thoughts on the Asteroids Act. I want to also thank Representative Posey for the partnership on the Asteroids Act. And I guess I want to ask about two things, one, value, and second, principle. Those were the two things that got me interested in the Asteroids Act. So I guess my first question to the panel is, what is there in an asteroid that would be worth the effort and expense of going to go get it?
You guys.
Well, so a variety of answers to that question. Some are purely scientific because we want to know how planets form, and asteroids are the building blocks of planets. We know from telescopic surveys and missions that have gone on that there's a variety of kinds of objects out there, rocky, metallic, etc. So there are pure exploration goals associated with that. And then there's a whole side of this business that cares about resources and the kinds of resources that future human explorers and settlers will need to live off the land, if you will. And asteroids are a potentially fruitful supply of those resources. Many people talk about metals and many asteroids based on the meteorites in our collection, which are from asteroids, have precious metals on them. But to me, I think maybe the most precious resource is probably water, H2O, because we need the water to live, of course, the O to breathe. The H can be an important part of rocket fuel. And so perhaps in the near term, and of course we're talking decades still for all this to happen, but perhaps the water inventory and water extraction efforts will be the most compelling.
I'd like to add to that. I clearly agree. In fact, there's a lot of interest in humans to Mars. Humans to Mars is a very expensive proposition, by the estimates that have been made. And I think that the only way that we're going to expand beyond low Earth orbit in any kind of significant way, human activity, is to find a way of living off the line, find a way of reducing the amount of material we have to haul up the gravity well of the Earth, the great expense. And asteroid resources, particularly the water, I think offers that possibility. But just saying it doesn't make it so. And there's a lot of homework that we need to do in order to determine whether that offers a cost-effective way of buying down the costs of expanding human exploration, enabling our going to Mars.
Thank you. The other thing I wanted to ask about, my background was working in economic development, and I worked with businesses professionally, and there was two things that drove my interest in this. One, we just talked about, the potential value of doing it, and the second is the sense that for businesses to make an investment, there needs to be some sense of certainty. My observation is what business wants from government more than anything else is an environment of trust and predictability. So I'd like to get some sense from you of is there value in setting some rules of the road as private enterprise contemplates pursuing any of these valuable aspects of visiting mines or mining asteroids for this purpose, and I guess relatedly, if a company fails in that endeavor, is there any risk to government or impact to NASA? Is there any downside?
I would say that having that legal certainty that when you go out there and acquire material at an asteroid, you're a private company, that you own it is very important. And at some point, that framework needs to be created to give private corporations that certainty, so that if they make that investment and actually go out and do it and bring stuff back, somebody doesn't say thank you and take it away from them. So that's important. In terms of risk to NASA, I guess I don't see that.
Okay, thank you. I yield back. Thank you.
I now recognize Mr. Hall.
Thank you, Mr. Chairman. And been a lot of exacting questions asked. I'll ask maybe some practical ones. I guess the first question would be how far away are the asteroids we're talking about, and how long would it take to actually reach a target asteroid? Not in inches or feet or half a mile, but just give us a good guess at it.
Congressman, asteroids are the easiest things to get to in the solar system. We swim in a cloud of near-Earth objects.
Does that mean they're easier? They're closer to us? Or?
They're closer to us. They're dynamically easier to get to. It takes less fuel to get to them. Not all of them. I'm talking about a portion of the population. I think there's a little chart in my statement from Rick Brinzel that shows how many of them you can get to with less energy than getting to the surface of the moon, and that you can do it with turnaround times of you get there on time scales of weeks, days, depending on how close it gets. So they offer a great variety of opportunity of access, easy access.
I guess I'd only add that that's true for a relatively random subset of them, and we may have to go farther to get certain kinds of asteroids. The more water-rich ones may be concentrated out in the main belt between Mars and Jupiter. So the answer is it varies. Some are close, some
Absolutely.
are farther away.
There's thousands, tens of thousands that we know about, and it's a fraction of them, and their orbits are random within range. We already know a large number that are easy to get to, and as we conduct space-based surveys to find these objects, surveys designed to find these objects, like the WISE mission that recently greatly expanded our knowledge of this class of objects. There's going to be many more targets, which is totally predictable.
Yeah. And I think it's fair to say that no matter which ones we want to go to, we're going to need the sort of infrastructure capability to get out into deep space, whether it's the government or a private company. Yeah. It's not going to be the low Earth orbit, medium Earth orbit kind of activity. This is deep space activity.
Mr. Brooks questioned what value you'd put on that and why spend the money, and are there specific goals? Even the chairman mentioned the question of harmful interference by either your testimony or our analysis of it, and who's going to have to pay for it. We know who's going to have to pay for it. But let me just ask another question. Is there any reason to think asteroid mining is not technically feasible? What's the danger in it? Why would it not be? You've talked about why it should be and what it's going to cost and how far away it is.
Well, in terms of the activity of doing the mining, is that what you're talking about? So it's a very challenging environment. There's almost no gravity on these bodies, and so most of mining technology on the Earth that we're used to involves gravity in some way, and at least being able to walk around and move equipment around. You're talking about very challenging environments, very small bodies where gravity is 1,000, 10,000 times less than what it is on the Earth. So I think there are some technical hurdles that need to be dealt with in how we operate. How do people even move around? Can we land on these objects? Do we actually dock with them? You know, very big challenges that need to get tackled.
This committee, several years ago, maybe 7 or 8 or 10 years ago, had a hearing on the dangers involved and how, where the asteroids were. Somebody there even asked if they dropped something in the middle of America, could you split it and let half of it hit New York and the other half hit Los Angeles? They couldn't answer that question either. But I guess, and we held hearings on asteroids, about the one that exploded over Russia. If the asteroid mining industry develops, will the resulting technologies help us to understand and interact with asteroids better and perhaps protect against an asteroid threat?
Congressman, I would say that yes, but we would need to be developing, we need to do a lot of homework before we do the asteroid mining, because asteroids are characterized by the diversity. They're going to have a variety of internal makeup, surface properties, and compositions. How do we work at the surface of an asteroid? There's a lot of homework that needs to be done, basic research that really is best done, I think, by us as a country.
I'll have just one more second.
Oh, sorry.
What recommendations, I'll ask you this in a letter to you later, that you'd make to provide that rules and a level playing field and let the market operate from there. And I thank the witnesses for your coming today, getting ready to come up here, arriving here, and giving us the testimony. I hope we use it wisely. I yield back, Mr. Chairman. I thank you.
I now recognize Ms. Bonamici.
Thank you very much, Chairman Palazzo and Ranking Member Edwards. And thank you to this impressive panel of witnesses. We're always fortunate, particularly in this committee and in this subcommittee, to have experts like you help us inform our decisions. One of the common themes that we hear about in this subcommittee, especially when we're talking about planetary science and human space exploration, is the role that NASA has had in sparking imagination, especially in the next generation. And when we've discussed missions before, we consider what NASA can do that will most effectively inspire the public so they can turn their interest to science and restore our sense of pride in our leadership role in space. And we've had some discussions already this morning about funding and budget levels, and it's my understanding that NASA's recent budget request for planetary science is low enough to force a withdrawal from the European Space Agency-led Mars mission in 2018 and focus instead on a U.S.-led mission in 2020. So I want to ask Dr. Greene, what might be the difference between a U.S. Participation in a European-led mission and leading our own mission, and would that negatively impact the collaborations that we've had with the European Space Agency or other international partners?
We work very well with our international partners, and ESA in particular. In fact, as was earlier mentioned, the Rosetta mission has 3 U.S. experiments on it and a significant portion of another, with more than 40 U.S. scientists that are analyzing that fabulous data that's coming in that's really inspirational in terms of trying to understand what these cometary bodies are and how they interact with the inner part of the solar system. As we move in other areas, ESA has a major desire to go to Mars. Their next Mars mission is a orbiter. It's in 2016. It's going to look at trace gases. And NASA actually has a part of that, a very small part of that, in terms of providing some electrical equipment that allows that orbiter to communicate with our surface assets, whether they are ESA assets or NASA assets. And then in 2018, we've also, although we've scaled back our interaction on 2018, we still have part of a major experiment that we work with the Germans on the 2018 rover. What's happened mostly in our interactions is really the scale of those interactions. In the missions I mentioned, we were actually a minor partner. This is how we've worked the best. One agency leads the effort for which the other is a minor partner and participates and follows that lead. And
thank you. I'm glad to see, and I'm sorry to cut you off. I want to allow time for another question, but I'm glad to see that there is still some role in those missions.
Indeed, we've worked very hard to keep our role.
Appreciate that. And I want to ask Dr. Sykes a question. I see you went to the University of Oregon.
Go Ducks.
I did as well. Go Ducks. Thank you. So another issue that we talk about here, and related to the point that I raised about inspiring the public again, I try to explain to our constituents why this is a priority. Oftentimes I find that the public does not understand all the technologies that have been developed through the space program that have civilian uses. There's lists of them, I think our constituents don't understand that, GPS, memory foam, solar cells, radial tires, and the list goes on, communications, smoke detectors, water filters, that they would not have those products to the extent that they do now without space exploration. So we're always trying to educate our constituency about why this is important. But I wonder, with federal investment in NASA lagging oftentimes when there are tight budgets, some have suggested that the private sector could end up developing technologies that NASA could adopt. And so, analogous to, but different from asteroid mining. So, are there good examples to date of private sector technologies being adopted by NASA for planetary science research or other purposes? Is there anything we can do to spur innovation in the private sector?
Well, I think the private sector is kicking off pretty well with SpaceX and Virgin Galactic and X-Core developing systems, some of which some of the SpaceX launch vehicles that will, I'm sure, ultimately be used for solar system exploration missions at a reduced cost. And so I think that we're benefiting from that right now, and it's opening up new activities in space through tourism. PSI is working with X-Core on the ATLAS Suborbital Observatory, where we'll send human-tended telescopes up into space to make observations, and I think that'll be pretty exciting.
Terrific. And I see my time has expired. I yield back. Thank you very much.
I now recognize Mr. Rohrbacher.
Thank you very much, Mr. Chairman, and I'd like to compliment you and Ranking Member Edwards for your commitment to America's space program and to keeping us the #1 spacefaring power in the world. So thank you very much. Dr. Sykes, I was actually taken by your opening statement that you felt necessary to apologize for being somewhat negative about a program. Now, let me just note that attitude, and all I can say is I commend you for then moving forward with being negative and expressing yourself on a program. What our problem has been in trying to set priorities has been that people and the witness stands have refused to tell us what is negative about specific programs. Over the years, I think that's I rarely have ever heard anybody say, no, this is not worth the money and we should cancel that part and we should finance this. If we're going to have a successful space program, we need people to be very frank about what they believe not to be worth the money. And they don't. Hopefully, they won't need to apologize about pointing out that this program isn't worth as much as some other program. But again, rarely do we ever get that. They're willing to express what they really want the money for, but never what they don't want money to be spent for. Now, with this, let me note that in your testimony, you were very negative about asteroid retrieval. Let me just note that that was not a condemnation, however, to the Asteroid Act, and nor was it in any way poo-pooing or trying to throw cold water on the idea of asteroid mining and commercial activity dealing with asteroids. So that is a very important point to note here, that you could have something that is a NASA program that deals with asteroids that may not be worth the money, but certainly trying to encourage private investor in the initial steps that are going to be necessary for them to be involved is a very positive thing. And we do need, I think this could be the very first step that was seen 10, 20 years from now, and then way beyond, maybe 50 years from now, we might see this as the first step towards something that was really valuable to humankind, in that we have private sector people bringing minerals back to the earth that we need for different types of industrialization. Let me go to Mr. Greene. One of the reasons why I just stress that people won't say what they don't think is worthwhile is we have certain projects that I have strenuously said we need to reconsider, and of course people know that the SLS program is draining about $1 billion a year out of the budget now. Could you tell me if, and I heard your answer earlier and it was kind of a little nebulous, but are there any planetary or space science missions that are at this point that the SLS would be a prerequisite to them, other than sending a manned mission to Mars?
Yes, I'll be happy to answer that. We have started interacting with Human Exploration, which is developing the Space Launch System, and we're finding that it has an opportunity to open up the outer part of our solar system. And what I mean by that is because of its large velocity injection from the Earth, it therefore enables a rapid transit from the Earth to objects such as Europa or other outer planets objects. But this is incredibly enabling for us.
So there's no other rockets right now that this multi-billion-dollar effort, huge expenditure is necessary, or we will not be able to send a mission by Europa. Now, by the way, I said I eliminated the manned part of it.
Yeah, currently if you compare what our conventional rocket capability is today, we would have to do a number of gravity assists on the inner part of our solar system that will eventually then give the velocity necessary for a spacecraft to go to the outer solar system. This might take 6 or 7 years. With a space launch system as currently being designed, we can cut that more than in half, and we can get to the outer solar system much quicker.
I will have to admit that cutting it the time in half does not necessarily justify the cutting of major other space-related programs to me. I mean, cutting things time-wise in half it's interesting for me to hear that, but I know that there are lots of endeavors. I mean, I forget what you're complaining about mainly today is this declining amount of money that's going into space, and what we see is in this administration a commitment to this mega project as well as to earth science, to a focus on earth science rather than planetary science, when we got lots of other federal government agencies and departments focusing on earth science, but NASA is the only one that focuses on space science. So I think that we've got to, number one, be very frank about what we think is not worthwhile, and we've got to make sure that the money that we spend is spent wisely, and maybe not just to cut the time frame in half at the expense of doing totally other programs. Thank you very much, Mr. Chairman.
I now recognize Mr. Posey.
Thank you very much, Mr. Chairman. And I want to thank all of the witnesses for your excellent testimony here this morning. Very informative and very inspiring, and we greatly appreciate it. Professor Grabrinowitz, I read just a couple comments in your written testimony and just one quotation. Given the ambiguities in existing space law, international space law contains many gaps in ambiguities.
Correct.
So, I mean, there's a lot of ambiguity already out there.
Correct.
You know, there will always be questions no matter what Congress does or doesn't pass right now.
Correct.
And referring to this legislation as you did, you know, in a way that you said it's logical to and appropriate to attempt to resolve these ambiguities in favor of the U.S. national interest, I am deeply grateful to see that in print, and I'm glad that we agree on that for certain.
But we may not always agree what's in the national interest.
Well, that's what's always debatable. I mean, you know, there will always be some people who would like to study this or anything else to death until the Russians, the Chinese, or somebody else takes the lead on this, as they have on so many other things. And so my question was, if you agreed that this is a good starting point, you know, or in other words, you know, do you think it's time to conduct a full-scale regulatory framework up front? Or do you think we should proceed with the draft a regulatory framework that has the flexibility to allow the industry and technology to develop further before we start putting all the regulatory framework in cast iron, which some people want to do?
I guess I would frame it differently, Congressman. I would frame it as follows. It needs to be recognized that what we are talking about is resource extraction, which is a very volatile and contentious issue at the international level. Therefore, it can be expected that there will be a great deal of political and legal discussion catalyzed by this. And what will be done is the language of the proposed bill will be analyzed in terms of current law, and it will be years before there's any agreement on that. That will create the environment in which this activity needs to go forward, and I think it's appropriate to understand that.
Yeah, well, if we wait years before we address the issue, the business just goes somewhere else. You know, and I guarantee you the Russians and the Chinese will not give the rest of the world the thoughtful consideration that some people expect before we do anything. Dr. Greene, there's concern in the science community about the inventory of plutonium-238, the fuel which powers long-distance robotic spacecraft. How much plutonium-238 is on hand right now?
Currently, the Department of Energy has allocated about 35 kilograms of plutonium. 17 kilograms of that is currently within specifications for us to use almost immediately, providing we have the manufacturing capability to put it in the appropriate form.
Okay. How many missions will that supply?
The missions are varied depending upon the amount of power they have. For instance, the next nuclear mission that is currently being considered is indeed we're baselining radioisotope power for the Mars 2020 rover, and that will need 4 kilograms. So we have adequate supply for that.
Okay. How many upcoming planetary science missions will require the use of plutonium-238?
Another one that we are considering, although it's also not been decided, is the potential Europa mission. That, once again, is in a pre-phase A and undergoing intense study. I think it's also important to note that our program, as delineated in the Planetary Decadal, in the New Frontiers area, has a number of targets that probably could not be accomplished without radioisotope power capability, and our intent would be at that solicitation to be able to facilitate that.
Okay. Was the purpose for requesting proposals for Discovery class missions that were not reliant on the use of radioisotope power systems reflective of the concern about the supply of plutonium-238?
No, they were not. Our concern was the assurance by Department of Energy that they could develop the pellets of plutonium necessary to fuel our radioisotope power systems. And that's based on a production line that has not been fully maintained. We, of course, are now working closely with Department of Energy to turn that around, and we anticipate them getting back into production of these pellets that will allow our missions to move forward in the next several years.
Thank you. Last year, NASA canceled its program to design an advanced Stirling radioscope generator that would use far less plutonium-238 per mission. What was the reasoning behind that, especially if there was concern about the amount of plutonium-238 available for long-distance science missions?
Yeah, I think it's important to recognize that what we canceled was the actual flight version of the Sterling capability. We currently have pulled that technology back into house. In other words, instead of having it manufactured, we are continuing to test that capability within the NASA centers. But we're anticipating that as we may need it, we will bring that technology back into the future.
Okay. Thank you, Mr. Chairman. I see my time has expired. Thank you.
I now recognize Mr. Schweikert.
Thank you, Mr. Chairman, and to Professor Christensen and Bell. It's nice to see ASU so well represented here. You know, it's I often talk to my associates here who are from back east who haven't seen the scale of what ASU has become, particularly in this last decade, and they don't understand. I believe we're now at the largest university in the country, and our hard sciences have done exceptional things. Mr. Chairman, and to the committee, this is sort of a one-off question, but I think it actually really does move towards the underlying legislation, which I fully support the concept. But we've seen throughout humankind, ownership is always is necessary for moving investment. But how do you do that in a world where there may be other treaty obligations, perception out there that these resources are sort of controlled either by the communal scientific community owned by sort of, shall we say, the collective of the populations of Earth. With us moving forward in a piece of legislation like the ability to own those resources and therefore move forward in doing the investments, when you participate in international organizations, how is this discussion moving forward? Is there at least now a communal understanding that private ownership or individual ownership of those resources will be required to make particularly private investments? Anyone willing to delve into this with me? I'm glad I created so much excitement. Professor Bell.
Well, I think it comes back to maybe it was Mr. Kilmer and others who pointed out that the companies need some assurance in order to make that investment. So if this is going to go forward, this problem has to be tackled. It's not clear, from what we've heard from today, it's not clear that there is a straightforward solution, but it is going to take time and it's going to have to be consistent with our international treaty obligations. So I don't think it's going to happen quickly.
One thought that comes to mind is if we are going to talk about advancing an industry, that it be an industry and perhaps not individual companies. And one thing in the language of the proposed bill, when they use the term harmful interference, it's referring to company A and company B, that if company A does something, then they are protected by this legislation from company B's harmful interference. Harmful interference has never been used that way in the treaties. That's a completely novel application of that term of art. And it gives rise to the thought that maybe we're not talking about an industry here, but we may be talking about the interests of individual companies. And if that's the case, then that's not going to get us what we want either.
Well, it's to that point. And forgive me, because in my reading through it, I actually took it as being even a little more complicated, because for any of us to predict what this industry, what this is going to look like a decade, 2 decades from now, it may be cooperative ventures, it may be public-private, it may be a series of multinationals, who knows? And so how do you design conceptually the framework in a fashion where we don't demonstrate a certain current arrogance that we know what the future is going to be, and that's sometimes very, very tricky to do. Is there, and Professor Bell, particularly to you, unintended consequences? And the basic word unintended means we don't know, but can you think of any sort of cascade out there as we move forward on trying to build the frame for this discussion that may sneak up on us?
Well, I can't think of any technical one. I think the cascading effects are likely to be as as was pointed out, political and perhaps related to treaty obligations. I think another way forward, historians would tell us to look to the past, and we could look at analogs for development of the airline industry or development of the telecommunications industry, and how these what we're seeing right now in commercial space is a lot of government seeding of these companies to help them with getting their footing, helping them to get some of the technologies under their belt that will help them attract investors, and so that's all moving out forward, and it's your guys' job to figure out the politics behind it.
And to that last point, I know I'm over time, and I would also ask you to add to that history the creation of the World Wide Web, which ultimately had very little government touch, and actually maybe our most successful in a century of reaching and touching and changing our lives. So with that, Mr. Chairman, thank you.
Did you want him to answer any questions? I mean, even though we're short, I mean, you're out of time, but we're coming close to the. Okay. Roger that. At this time, for the purpose of being fair and inclusive to all our witnesses, we're going to open up a last round of questions or question, and I will recognize Ms. Edwards.
I just want to thank the chairman. We want to make sure that none of our witnesses, Dr. Christensen, gets to escape without answering a question. And so mine is for you, and it was prepared for earlier, but in your prepared notes, you indicate that a sample caching system is a major new development of the Mars 2020 rover mission and should remain the focus of the mission. But in really simple terms, what we know is that caching involves the rover carefully collecting a suite of high-quality samples to be returned to Earth by future missions. Are you concerned that the caching system is not a priority for Mars 2020? And then related to that, if you could give us an indication of the ways in which the planetary science is actually an enabler for human exploration missions, because we like to see that there's some synergy between what we're doing in what I described sort of the multi-mission focus of NASA. How is that planetary science related to the human exploration missions?
Sure. I think it's very important to remember the Decadal Survey spent 2 years looking at priorities across planetary science. And Mars came to the top of that, not because of another Mars mission or another rover, but because of those samples coming back to Earth. And there's a lot of pressure on actually fulfilling that series of missions. The first rover its main goal is to collect that cache. And the concern is that if that is not kept at the highest possible priority, then the entire campaign is threatened, and then the whole rationale for making that mission the highest priority comes into question. So it's a more of a cautionary note. It will be difficult. It's a complex system to create. We just need to make sure that NASA stays focused on that goal.
I mean, it's not your view, though, that talking about human exploration missions or even investing in those is a distraction from those commitments?
I don't believe so. I think within the planetary science community, we have this very high priority, and that's to get samples back robotically from Mars. To tie to the humans, I think it's essential that the robotic science program and the human programs are connected. We all wish there was a better connection between them. Everything we're learning is going to inform us so we can safely send humans to Mars. So we think of the science part as the precursor, the very beginning of eventually getting humans to Mars. They're closely tied.
And do you think our budget considerations, I mean, where I mentioned now we're at $1.345 billion for planetary science, is reflective of that commitment?
On the planetary side, we're concerned. In the previous decade, we could have fulfilled the goals and recommendations in the decadal survey. So planetary science doesn't need a vast amount of new money. It needs to be restored to where it had been for almost a decade. The scope of planetary exploration, robotic and human, is so different that there's the threat that human exploration can take money from the planetary science side. But I think most of us believe that there's actually a very reasonable divide between those two, and the planetary will continue forward successfully.
Thank you. And Dr. Greene, do you share that?
I do. I am also looking closely at Mars 2020 as we develop it further to ensure that it is decadal compliant. I believe the planetary decadal is a fabulous document. You know, it's a consensus within the community, and it's really part of my drive to make planetary science successful is to follow the decadal to the best of our ability.
Thank you, Mr. Chairman, and I yield.
I now recognize Mr. Posey.
Well, thank you, Mr. Chairman. I just wanted to make it, again, abundantly clear that the letter that you entered into the record at the beginning of this meeting makes it very clear that we have Americans ready, actually waiting right now, to pursue asteroids as we speak, not in 2 or 3 years when Congress finishes studying it together and then moves forward to the gridlock that won't do anything. I mean, this is imminent right now, and I'm just so glad to see you take this action on it. Dr. Greene, currently the United States is the only country able to produce plutonium-238 for use in long-distance science-based missions. If the United States fails to produce enough plutonium for our civilian space program, how likely is it that other countries will develop the capability to send missions to the outer planets of the solar system?
I feel very confident in our relationship with the Department of Energy and the support of the administration and the wonderful support that we get from Congress to be able to begin the production of plutonium. We're very much on track to be able to do that. Working with Department of Energy, we've actually started to test that process. We've generated very small amounts of plutonium in one of their existing reactors. We've extracted that, and we now are, through Department of Energy, developing the procedures and the processes to safely do that at about 1.5 kilograms of plutonium oxide every year. That will meet our needs. And I believe that that will secure our future of NASA and its approaches to going to places where there's very low light, whether it's the pole of Mars or crawling in a permanently shadowed crater on the Moon or Mercury, or going out to Pluto or Neptune or Uranus. So I think we're poised now to be well-positioned and good stewards of a planetary program by your support in getting the funding necessary for us to regenerate plutonium, and that's on track.
Okay. Thank you, Mr. Chairman. I yield back.
Thank you, Mr. Posey, and I truly want to thank the witnesses for their valuable testimony and the members for their questions. The members of the committee may have additional questions for you, and we will ask you to respond to those in writing. The record will remain open for 2 weeks for additional comments and written questions from members. The witnesses are excused, and this hearing is adjourned.